In this lesson, we're going to be using the angle addition postulate and angle bisector. So if we had a situation of D where D is in the interior of angle ABC, so let's go ahead and draw that first. We have angle ABC, and then we have D in the interior. Remember, interior means inside. Then I'm just going to draw a ray through that point. So if this is the case, then we can say that angle ABD plus angle BDC is equal to the larger angle ABC. Okay, so that's how we can write it using the names of the angles. And what if I said that the measure of angle ABD is equal to 60 degrees and the measure of angle DBC is equal to 40 degrees? Well, we can say, or we can substitute this value. You've got 60 degrees is ABD. The measure of angle DBC is equal to 40 degrees. And that's going to give us the measure of angle ABC. And 60 plus 40 is 100. So the measure of the larger angle ABC is equal to 100. So this whole thing is 100. Okay, so if we look at this problem, they're asking us to find the measure of angle FGH. So FGH, so we're looking for this larger angle. And they're giving us FGB, so FG and B. So this angle right here is 105. And then we have the measure of angle BGH. So BGH, this angle right here, equal to 54 degrees. So let's go ahead and write the equation for the angle using the angle addition postulate. We have the measure of angle FGB plus the measure of angle BGH. So the two smaller angles, when we add them together, we get the larger angle, the measure of angle FGH. So let's go ahead and substitute. Measure of angle FGB is 105. The measure of angle BGH is 54. That gives us the measure of angle FGH, and that measure is 159 degrees. Now there will be a case where you have an angle measure where, let's say they give us, I don't know, this is 36 degrees. Let's say, for instance, they give us this problem here where we have the measure of angle AST. So AST, this larger angle, is equal to 176 degrees. Then the measure of ASE, angle ASE, so this is ASE, which is this part right here, is equal to 36 degrees. Then in this case, we would not add. In this case, we would subtract. We would get the larger angle, which is angle AST, subtract the measure of angle ASE, the smaller one, and that gives us the measure of angle EST. So we would say 176 minus 36 gives us the measure of angle EST, which is this angle right here, and that gives us 40 degrees. I'm sorry, 140 degrees is equal to the measure of angle EST. So this is 140 degrees. Okay, now let's put some algebra into the angle addition postulate. We're looking for the measure of angle BAC. So you always want to put it aside so you know at the end that you did answer the question that it was asking for. In this case, we're looking for BAC. We're looking for this angle here. Okay, they give us the angle of BAC right now. They give it to us as an expression. So this is 3x plus 10. Then they give us the angle measure of CAD. CAD is this one here. And that angle measure is 42 degrees. And then finally, the angle of DAB. So DAB, so we're looking at this big angle, and that one is 8x plus 12. So using the angle addition postulate, let's write down the angle. We have the measure of angle BAC plus the measure of angle CAD is equal to the measure of angle DAB. So the two smaller ones are equal to the larger one. So we have 3x plus 10. When we substitute, CAD is equal to 42, and DAB is 8x plus 12. So now all we have to do is combine like terms, because we're solving for x. 3x plus 52 equals 8x 12. Subtract 3 from both sides. 52 equals 5x plus 12. Then we want to subtract the 12. We get 40 is equal to 5x divided by 5, and x is equal to. Notice how it has not answered our question. Our question is the measure of angle BAC. So we use the expression 3x plus 10, and now we're going to substitute our x value that we have just solved for. 3 times 8 plus 10, and this is 24 plus 10, which gives us 34. So the measure of angle BAC is 34 degrees. Now we're going to look at angle bisectors. Remember, bi means two. Sectors is, more specifically, for bisectors, it's two equal sections. So bisectors come in different forms. They can come as a line. They can be a segment. Or they can be a ray. But when no matter what type it is, they will always divide the angle into two equal parts. So your bisector is a lot like your midpoint. All right, so let's look at this problem. We've got ray OC. So there's ray OC is the angle bisector, two equal sections. So that means that this angle and this angle are equal to each other, because we're bisecting angle AOB. All right, so what if I told you that the measure of angle AOB is equal to 60 degrees? So let's highlight that, AOB. So this whole thing is 60 degrees. Well, since it's going to be, the bisector cuts it into two equal parts, then we can say 60 divided by 2 is 30. So that means that this angle is 30 degrees and this angle is 30 degrees. So we can say that the measure of angle AOC is 30 degrees and the measure of angle COB is also 30 degrees. Okay, let's put some algebra in it. We've got ray JL is bisecting, again, bisects equal, and it's bisecting angle KJM, which means that this angle here is equal to this angle here. Let's use our congruency marks. This is equal to that angle. Okay, let's label the angle with information given. It says the measure of angle AJM is 3x plus 5. So LJM is 3x plus 5. And then KJL is 5x minus 19. So that's the only information we have. We need to calculate angle, the measure of angle KJM. And KJM is the larger angle. Let's write down what we need to find. So we know that we answered our question at the end. So based off of the information that we have, all we can say is the measure of angle KJL is equal to the measure of angle LJM. So let's substitute. We've got KJL is 5x minus 19. LJM is 3x plus 5. And then we just solve. Subtract 3x from both sides. This gives us 0. 2x minus 19 equals 5. Add 19. And we get 2x is equal to 24. X is equal to 12. But we're not done yet because the question is asking us for the measure of angle KJM. So we can use either one of those equations. I'm going to choose the one with the smaller numbers to substitute my x. So it's 3 times 12 plus 5. We get 36 plus 5, and that's equal to 41 degrees, which means this is 41 degrees. And if that's 41 degrees, this other angle is also 41 degrees because of that angle bisector, which means the whole thing is 82 degrees. So the measure of angle KJM is 82 degrees. Now, what if I ended up wanting to use that equation, the measure of angle KJL? So we can use 5x minus 19, and then we substitute 12 minus 19, 60 minus 19, and that also gives us 41. It really doesn't matter which expression you use, you'll end up with the same answer.